Hi, my name is Bruce Slutsky. I'm a reference librarian at the Robert Van Houten Library here at NJIT. The purpose of this lecture is to teach students how to find information in chemistry, chemical engineering, and the environmental sciences. We're now in this internet age. We've been here for a good 15 years right now. And students very often fall into bad habits that people always fall in love with Google. They think they can find anything they want by searching Google. But in this lecture, I will introduce you to many of the information resources we have here at NJIT to support the curriculum. Feel that it's my job to explain to you what resources we have and how to use them to your advantage. So we'll go through this slideshow here, and then I will give a few examples and show you how to use the various databases that we have here related to chemistry and chemical engineering. That information-seeking skills is quite important for your time here as a student at NJIT, whether it's to support your coursework or research, but hopefully you'll bring these skills forward with you as you move on perhaps to graduate school here or another university, or eventually into industry, to know how to find information in your field of expertise. So we talk about the scientific method, which scientists use to construct an accurate representation of the world. And when using the scientific method, you have to know the thought processes involved in designing an experiment, revising it perhaps, and interpreting the results. When you're looking for information, you need it at all levels. It might be basic information or state-of-the-art information. So you must need to know what resources are available to you and how to use them. So there's similarities between the scientific method and the method that you use to retrieve information. So I still think in terms of how a chemist would think, that you know your subject, you're acquiring new knowledge, you propose an experiment. It may be to synthesize a novel chemical substance. You absolutely conduct the experiment. Experiment takes time. Some are very fast, some are very slow. But then you must observe and interpret the results. Very often you have to revise the experiment. Maybe you need a different reagent, maybe you need to change the time of the reaction, or so on. And you interpret the final outcome of the experiments. When you're looking for information, you know the scope and content of the databases in your field. And we'll explain that to you later in this presentation. You're looking for new knowledge. You want to know what's been published in the past. So you devise an initial search strategy using the relevant terminology in the subject databases. Okay, computers are very fast, so it may take only seconds for the computer to execute your search. But then it spews out an answer set, and it takes time for you as the researcher to interpret that data. And then you must revise that strategy based on the information that you found. Is this what I'm looking for? If so, fine. You may not have to revise your search. If not, you may have to do a new search strategy. So you explore the alternative search options, examine the final answer set, find the relevant documents, and use the information found. So computers are very fast, but people are very slow. And people must use their knowledge to interpret and evaluate and use the information that you find. So we're going to discuss now the scientific and technical literature, the various formats that I have here on this slide. We'll do it one by one and discuss how the information goes from somebody who's creating it to somebody who's using it at a point in time in the future. Okay, what is a journal? A journal is a publication issued periodically that reports original research. So periodically could be weekly, monthly, or quarterly. There are very detailed articles with experimental procedures. They're highly specialized, and the articles must undergo the peer review process, and I'm going to discuss that in detail right now. It's a very important concept. Perhaps it was discussed in earlier courses that you've taken at NJIT. Okay, a scientist writes a paper and submits it to a journal. Okay, all journals have editors. So the editor takes the manuscript, sends that paper to other specialists in the field for anonymous review of the quality and originality of the research. Now, it's a double-blind process that the person who writes the paper does not know who's reviewing it. The person who's reviewing it does not know who wrote it. And he examines, was the work done properly? Is this discovery original? That materials in scientific journals are original research? Is the subject appropriate for this journal? The journals are often very specialized, so it might be good research in a well-written paper, but not appropriate for that specific journal. Will other scientists be able to understand and repeat the experiments with the same results? Reproducibility, that's very important. When an experiment is done, it must be done properly so that somebody else can repeat the same results. And the editor gets a response from what's known as the referees, and the editor can accept the paper, reject it, or maybe accept it conditionally and ask that revisions be done before it's accepted for publication. There are probably hundreds, if not thousands, of journals in chemistry and chemical engineering. So I have here a list of only 5 that's in the fields of chemistry or chemical engineering. But let's take a look at one of them. Let's take a look at the Journal of Membrane Science. Okay, we'll see how the journal is organized and all. It gives me, by default, the most recent issue of the Journal of Membrane Science. And you likely would have to go through, very often you need a back issue, but this is for demonstration purposes. We'll just see the current issue. So let's take a look at this paper number 5. Poor blockage of organic fouling layer with highly heterogeneous structure in membrane filtration. Role of minor organic foulants. So you see from that title of that paper, it's very specialized. If you're doing research in that area and you want to look at a paper, you can just click on PDF here. Okay, we've had this capability now for about 15 years. So you'll see here's the entire paper. And what's most important here is this one paragraph abstract. The abstract is a summary of the article. Very often these journal papers are very long. You may not want to read all of it. Maybe you just want to get the gist of what it's talking about. So this one paragraph abstract is indicative. It helps you judge if you want to read further. Is this article of interest to you? So if you look at this journal article, you see there's an introduction, materials and methods, results and discussion. There are a lot of diagrams, graphs, charts. Okay, supplementary data, and you see at the end of the article there's a list of references. Those references might be very useful to you. So very quickly, that's how a journal article is organized. Very detailed, very structured, and enough information in there so that somebody else can repeat that experiment. Another place where original research is revealed is at a professional conference. So organizations like the American Chemical Society or the American Institute of Chemical Engineers often run conferences where scientists and engineers report their research findings. So the conference proceeding is a permanent record of that presentation, of the research that was done and reported. Conference proceedings vary. Some of them are one-time events. Others are held regularly, could be yearly or every 2 years. So on this slide, you see an example of, two examples of conference proceedings. So they're held all over the world. One in Italy, one here in Greece. Very important source of original research. A review journal is a condensed version of a research journal that we saw before from that Journal of Membrane Science article that was very detailed. So the articles in a review journal just summarize what was done, and they omit the detailed experimental procedures, but they give you a reference if you want to look at that experimental procedure and repeat the experiment yourself. So a couple of examples are the annual review of biochemistry, the annual review of physical chemistry, or chemical reviews. A magazine, you all know what magazines are, but there are scientific and technical magazines, and they're translated into a language which is suited for a more general audience. And many of the articles in the scientific magazines are written by journals, not by the actual researchers. So there are some that are for scientific and technical people, like the Chemical and Engineering News. If you're a member of the American Chemical Society, you receive that. There's Chemical Engineering Progress, received by members of the American Institute of Chemical Engineers. Chemical Week is like a business magazine. And there are also scientific magazines for the general public, like Scientific American or Discover. A monograph is just another name for a book, written at all levels, and there are research level books, and that reports research done over a longer period of time, and it brings those research results to a much wider audience. Okay, a data compilation. I discussed this in more detail for undergraduate students taking Math 225. They extract selected pieces of information from the journal literature. They may be limited by the type of compound or property, and they can be print or electronic. So a few of the data compilations here. ChemSpider, that's a relatively new one on the internet. I hope you're all familiar with the CRC Handbook of Chemistry and Physics. There's the NIST JANIF Thermochemical Tables and the NIST Webbook. Okay, encyclopedias. There are general ones that have been around for many years, but there are also some of those in chemistry and chemical engineering, which introduce researchers to the specialized fields of study. So a few of the encyclopedias that we have here at the NJIT Library are the Kirk-Othmer Encyclopedia of Chemical Technology, Ullman's Encyclopedia of Industrial Chemistry, Encyclopedia of Polymer Science and Engineering, and then our new friend, the Wikipedia. Okay, students and even the general public like the Wikipedia, but is it reliable? Can it be trusted as a source of chemical information? So it has advantages and disadvantages. Let's go over the disadvantages first. That obviously anybody can write an article and anybody can edit it. So it doesn't undergo that rigorous peer review process. When you see an article in a Wikipedia, you don't know who wrote it. Could be a high school student. You just, never know. But the advantages are that it's up to date, since people can change it all the time. It's easily revised. And it's good for obtaining background knowledge on a topic. So I would advise students that maybe if you don't know much about a topic, just peruse through the Wikipedia just to get a little bit background information, but also to seek out more specialized sources on your topic. Very often the bibliographies in the Wikipedia are very good and reliable, but they're not exhaustive. Now there's a flow of scientific information from somebody who creates it and somebody who needs it. The person could need it very shortly after publication or many years later. So the scientists and engineers conceive ideas, conduct experiments, write up a paper, publish it in a journal. And when they want to publish it in a journal, that information is public information. Anybody can get to it. So we'll see the chart on the next slide, which shows how information flows from somebody who's creating it to somebody who's needing it. And you see here that you'll start out at the bottom. Students, when you're doing research, you want background information on that topic. So you would use what was known as the tertiary literature, handbooks, encyclopedias, and textbooks to get the background information on a topic. If you need more specialized information, you would use what's known as the secondary literature, books, reviews, and so on. But if you needed that state-of-the-art information, you need articles, journals, and conference proceedings. But how do you get at that? In the print age, we would call those index and abstract publications, but now those publications are known as databases. So you need to use a database to get at the more recent information in the journal or conference proceeding literature. So let's discuss now databases, the types of databases first. There's the bibliographic database. We'll see those a little later. Those includes the elements needed to identify the document, the author, the title, the name of the journal, the year, the volume, the issues, and the pages. But most databases have abstracts. We saw the abstract in the article from the Journal of Membrane Science. So that's a one-paragraph summary. So you do a database search, you'll get an answer set, and the answer set has those abstracts, and you can peruse those abstracts as an indication whether the article you've retrieved has the information that you need. There's the full text database, which includes the entire article in electronic format. And very often you'll see that the bibliographic database gives a link to the full text database. Okay, the numeric data compilations, I discussed those in Math 225, like the NIST web book and ChemSpider. The history of database formats. Students today were born with a chip. They know this whole computerized era, but it wasn't always that way. That back years ago, we only had print, and print resources are very cumbersome and difficult to use. But as the timeline goes forward, we get into the 1970s, we're in an online version. Remember, computers 30 years or so ago were not the same as they are today. They were very primitive. They were text-based. You couldn't get graphics. You'd have to dial into a service to access a database and then pay for the time that you were online. So that kind of morphed into the CD-ROM era in the 1980s. But only so much information can fit on one disk. So that was a disadvantage that we had 25 years or so ago in using CD-ROMs, and they couldn't be networked. But as we got into the 1990s, and when I came to NJIT, we were at the World Wide Web era, where the databases were on the web and you can access them from anywhere. Okay, the limitations of databases. Subject coverage. No database is like Google. There's a limitation on the subjects that it covers. The journal coverage, that no one database can cover every journal in every field, or in chemistry or chemical engineering. The dates of publication. Most likely the more recent information is in the databases. Full text. Not all databases are full text or have links to the full text of the articles. Okay, so we'll discuss some of the databases here that we have here at NJIT that are related to chemistry and chemical engineering. Scifinder Scholar, Scopus, Medline, American Chemical Society publications, and Science Direct. The top three are bibliographic databases. The other two at the bottom are full text databases. Okay, Scifinder Scholar. Okay, that's the electronic version of chemical abstracts from 1907 to the present. So chemical abstracts made transitions through the years based on the information technology that was available at that time. For many years it was only available in print, but then it became available electronically, and I think it was 1999 at NJIT that we first got access to Scifinder Scholar. Okay, it contains links to full text articles, and you can search it by chemical substance, reaction, research topic, author, or affiliation. And when I finish with the slideshow, we'll actually access Scifinder and do a couple of sample searches. Okay, there are actual guides on how to use Scifinder. In this short time that I have to give this presentation, I can only discuss so much, but if you go to this URL here, there are guides on how to use Scifinder. Years ago, we used to have to go to conferences and people from Chemical Abstract Service would teach us how to use Scifinder. But in this day and age, there are little webinars, there are YouTube presentations on how to use the various operations to search Scifinder. Let me discuss at this point what's known as the Chemical Abstract Service Registry number, where you can search chemical substance. Every chemical substance has a unique numeric identifier. So if it's cis or trans isomers, RNS enantiomers, labeled compounds, every unique substance has its own registry number. That number in itself has no chemical significance, but it's a link to a wealth of information, be it in Scifinder Scholar or in other handbooks on a chemical substance. Okay, Scopus. Scopus is a relatively new database. I think it's been around about 8 years. It's multidisciplinary. It's not limited to chemistry-related topics, but it has records back to the 1960s. So it was created maybe about 2003, but it does go back in time, and it has links to the full text of the article. So each database is different in its coverage, different in its visually, different in its search interface. So when you need an exhaustive search, it's always best to use more than one database. Okay, now Scopus has an app on the iPhone, and also Scifinder Scholar you can search on a smartphone as well. There are various publisher databases here at NJIT. So you see there are essentially two types of publishers. There's a professional society publisher and a corporation that publishes. So American Chemical Society journals is a professional society, Institute of Physics, and so on. but Science Direct, Elsevier. Elsevier is the world's largest publisher of scientific, technical, engineering, and medical information. Elsevier is also the publisher of Scopus. Springer and Wiley are for-profit organizations in the publishing business that have the publisher databases. So very often you'll do a search in Scifinder or Scopus and it will lead you to the full text database which has the actual article that you need. Okay, here's a list of American Chemicals, a few lists, selected list of American Chemical Society journals that we have here at NJIT. Okay, we have the American Chemical Society archives. That has all the American Chemical Society journals from their inception until 1995. But current subscriptions were selective with the American Chemical Society journals, that no library can afford all the journals that we really need. So we're selective in the American Chemical Society journals that we have currently. Okay, Science Direct, again, that's Elsevier. So here's a list of, selected list again, of the journals that are in Science Direct that are relevant to chemistry and chemical engineering research done here at NJIT. The availability of journals. Okay, some journals are print only, but we're rapidly moving away from that. That there are so few print journals available today that we're in an era now where almost all the journals we get are electronic. But very often there's a split that perhaps before a certain date, journal available print only. After a certain date, it's available electronically only. So the more recent the information you need is, the more likely it's available electronically. Okay, open access journals, that's new. That's a mode where everybody has access to the journal. Okay, it's not a subscription-based model. Okay, and not every journal is available at NJIT. We have an Interlibrary Loan service where you can order articles. Okay, when I get out of this PowerPoint presentation, I'll go through the NJIT Library homepage, library.njit.edu. That's the link to the resources that we have here for students and faculty and staff, not just chemistry related. I'll go through some of these later. Okay, so Voyager is the NJIT Library catalog. I'll show you that as well. Interlibrary Loan, as I mentioned a minute or so ago, that the NJIT Library staff locates books and articles that are needed by our researchers that we don't have here, that we use other universities to get these materials, and likewise other universities come to NJIT for books and articles. But I'll show you also the form that you need to fill out. Please be as complete as possible when submitting a request for an article or a book, because if you're not complete, it'll just delay your request. The advantage of electronic journals and electronic resources in general, it allows for remote access. Years ago, you had to come to a building called the library to do your research, but now you can do research from your laptop, iPad, or smartphone. Okay, they allow links to references in the bibliography, and they're usually both HTML and PDF versions of their papers. Okay, I have compiled a selected list of chemistry and chemical engineering sources on the web. There's the URL for it, researchguides.njit.edu/chemistry. I'll show you how to get to that in a little while. I have one on physical properties, which I show to the students in Math 225. Okay, when you do a database search, it's all based on Boolean logic. Same thing with Google. You know, the Boolean logic is implied, that the AND narrows your search by retrieving only documents that contain every one of the keywords that you enter. So example would be vapor, liquid, equilibrium, and benzene, and toluene. The Boolean OR expands the answer set. Benzene or toluene or xylene. The NOT limits it. So, for example, benzene, not chloroform. So your optimal search strategy is based on finding the most appropriate search terms with the best Boolean logic. So when you have a search question, you choose the proper databases. Sometimes one is enough. Maybe you don't have to be exhaustive, but know your databases, know how to search them, be aware of their scope and limitations. So use the relevant search terms and appropriate Boolean logic. Think in terms of concepts, not words. Devise a search strategy that could be precise. Very often you only need a few articles on that topic, but when you have a precise search strategy, you run the risk of missing articles. Exhaustive search, you know, very often, especially in your industry, you want to avoid any problems infringing on somebody's patents. You try to be too exhaustive, you run the risk of finding irrelevant information, and you just have to spend the time going through that information and eliminating it. Is your answer reasonable? You know, when you go through a search question, you should have some background information and have an idea, is the information you're finding on the mark? If not, what can you do differently? And always keep in mind that the computers that you're using these days are very fast, but they can't think for you. You're the ones who have to evaluate that information. So the thought processes involved in evaluating information is also the same as evaluating what was done in a scientific experiment. So again, we have a reference desk in the library. There's the phone number for it. We also have chat reference. We're also on Twitter, if you want to follow us there. We're also on Facebook, Friends of the NJIT Library. In this era of social networking, this is kind of helpful. And that's my name. My name is Bruce Slutsky. Anybody is always welcome to contact me. That's my email there or my phone. We're very happy to help you out. Okay, there are some chemistry, chemical engineering resources for the smartphone these days. Probably is a very small list here. There are certainly a lot more available. Probably as I speak here, there are more and more apps being developed. So I have a couple of sample search questions, but before I get to that, let me go through the library homepage. So the library homepage is library.njit.edu. Okay, so that's our starting point. So let's find books and more. This is the library catalog, keyword, subject. We can do a search here on membranes. And it'll give you a list of books that we have on membranes. Okay, we also have an advanced search mode also. We can use that Boolean logic. Now, I mentioned before that more and more books are available. I mentioned before about electronic journals, but now more and more books are available electronically. So if you see, I do the search here, so many of these books are available digitally, and you're certainly welcome to use them. Okay, See so many of these. Biological membranes, and this one here, number 11, membrane technologies and applications. So that's certainly those books are available for you to use. We'll go back to the library homepage again. Let me go on to services here. Services here is Interlibrary Loan. So you need your library barcode and name. As I mentioned before, if you do need something through Interlibrary Loan, please give the full information, or else it just might delay your request. Okay, going back to the library homepage here. We have here databases by subject here. So if we look under chemical engineering, here you'll see the databases that are relevant here. Okay, the most important two are Scifinder Scholar and Scopus. So we'll get to that in another minute. I just want to show you, back to the library homepage, those research guides that we have. You click on where it says Find Research Guides here, then click on the Subject Guides, and you click here under Chemistry and Chemical Engineering, and you'll see a list of resources. I've kind of compiled these resources over the years I've been here at NJIT, and you're certainly welcome to take some time to peruse them, and some of these, might be useful to you here. Okay, so that's a general list of resources that I have here. Now here's one here, mobile apps in chemistry and related sciences. I have two here, but then there's a list of resources for the iPhone or the iPad. So certainly take a look at those. We go back here, how to find physical and thermodynamic properties of substances here. Okay, again, take some time and go through many of these resources that we have access to. Most of them are on the public domain, so you can get to the resources from anywhere on the web. Okay, so let's go back, library homepage. Okay, and I had two sample search questions here. Find information on the removal of volatile organics by membranes. So what we'll do here, we'll use Scifinder and Scopus. And, okay, chemical engineering. Okay, let's try Scifinder first. Okay, now one little difference with Scifinder, all the other databases that we have at NJIT, is that you have to set up an account. You only do it once, and once you have that account, it's good for as long as you're here at NJIT. So here's the information how to register. It should only take a few minutes. They'll send you something to your NJIT email to verify that you're an NJIT person, and then you're all set. So we'll go here, we'll connect directly to Scifinder on the web. Okay, I have a username and password. Okay. Okay, so you see the search box here resembles Scopus. So you can search by author name, company name, so on, explore references, explore substances, explore reactions. So I won't just do one search as an example. So I can say here, removal by, the box looked like Google, removal by membranes. So again, the Boolean logic is understood as a Boolean and. So again, it takes a couple of seconds to search. So you see here it says 327 references were found containing all the concepts: removal, volatile organics, and membranes. So let me click here, get the references. You probably don't want to see 327 references. Okay, but okay, you see that it's the most recent come up first, the 2012 publications. So what you would want to do here, let's refine. I only want to see English. So I get my language, English, refine. Okay, down to 221. Now let's say I only want journal articles. So I would say here, refine. I only document type. I only want journal articles. I don't want any of these other materials. Okay, down to 162. So you see that the abstract is right here. So, okay, let's say you like this number 1 here. This looks like it's what you're looking for. The title is Volatile Organic Compound Removal by Membrane Gas Stripping Using Electrospun Nanofiber Membrane. Okay, so if you like that, and here's a little summary here, the abstract. Click on here. Then, if you really like that, you go click on full text. Okay, then HTML from publisher. Okay, so the journal is Desalination, which is an Elsevier journal. So went into Science Direct. So we went from Scifinder into Science Direct, and okay, and there should be something here for PDF. We like that article, and here's that article in full text. So again, you'd have to go through that whole retrieved references and pick out the ones that answer your question. Okay, so here's the entire article here. Okay, let's try this search in Scopus. This you don't need for now. Okay. So let's go now back to the NJIT Library homepage, and let's get Scopus, and we'll do the same search. So you see here, as it comes up, that the search interface is different. Let's add a search field, and you see here it gives you the Boolean and. It gives you, you can or not it. So I'm going to say put 3 fields here. Add search field, removal, and volatile organics. By membranes. Okay, execute the search. Okay, the same article here in desalination. All right, so you see there is overlap between databases. Now, you see here the 2012 publications are coming up first. But what I'll do, I can have the option here, this is something I can do in Scopus but not in Scifinder, is search by relevance. Sort by relevance. And say here, let's try this one. Number 4, removal of volatile organic compounds from water by pervaporation, da-da-da-da-da-da. So you click here, Okay, again, this goes into the full text of the article here. Okay. Okay, view it, publisher. That's the abstract here. Taylor and Francis is another publisher. And Wolf view text. Download full text. Okay. There you go. Okay. So that's that whole article there. Okay, that was done in China, but it was in the English language. Let's just try one more sample search, and then we'll end our little tutorial. Okay, so the other I had here was use of Adderall to treat attention deficit disorder. Now, I'll show you how to search in Scifinder, explore substances. So Adderall is a substance. So click on substance identifier, Adderall. So very often, especially with drug substances, they have different names. So that gives me, here's the registry number for Adderall. That's the chemical structure. I click on here, I'll get more information on that substance, all the various names for it, and gives you some property data. And then I can search on, get references. Let's say you want biological study. Okay, and then I'm going to say, I'm going to refine, and I'm going to put here attention deficit disorder. Okay, refine. Down to 554, and I can analyze the articles to see if I want them. And then do the same step to click on it, see the whole abstract, and then click on full text and see if the article is available in full text. Okay, and then we sign out of Scifinder. Okay, and we can do the same search in Scopus. Again. Okay, let's reset the form. Okay, we say Adderall, attention deficit disorder. Okay. Okay. Okay, there were 603 hits here. And there's a lot more you can do with Scopus, but in other different specialized operations, but I really just don't have the time to go through it here. All right, so what we do here, we can sort by relevance. And again, the same thing is to look at the article, look at the abstract, and click on the full text link and retrieve the article. Okay, so again, thank you very much for your attention to me for this about 45 minutes or so. If you need more help in using the resources of the NJIT Library, I'll repeat my name, Bruce Slutsky. You'll find me in the Van Houten Library, and I'm always pleased to help you.